All right, so we're going to be talking about Lab 8 with the 2 4-bit adder, meaning just like in Lab 1 where we use this bank of dip switches to create a 4-bit adder, we will do the same thing in Lab 8, only this time instead of using C code and writing everything ourselves, we're going to have Simulink help us out. So if we go into here, so I'm going to go into my MATLAB solution. And I'm going to go to section 2 to my 2 4-bit adder. So sorry, that was a little cut off. But if you see here, we went into MATLAB, into Lab 8, into section 2, my 2 4-bit adder. So I'm going to open that up. And so I already had it pretty much open already. So as you can see here, we had this adder task, which is pretty much going to be what your pre-lab had, just like adding 2 4-bit numbers together. And we have some other stuff to take care of, uploading to the board and making sure all the LEDs function properly. So then in Simulink, we're going to build. And then if you look here closely, we have this download code after build. That's going to let us ignore having to upload the code ourselves. Sometimes we'll ask you to do that, sometimes not. Since you guys won't have to actually do it, I'm just going to upload it straight to the board. And so what's happening here is these blocks then need to be translated in a way that the board can actually understand. So it needs to be created into source code. So into that C code that we've been creating already, Simulink is doing that behind the hood. It's creating source code, and in this code generation report, we can tell that it's done that because it tells us where it's put that source code. So if we look here, it says, okay, cool, in that folder where your MATLAB is, I've also placed the source code that's created and uploaded onto the board. So what we're going to quickly do is go back here. So here we are at that folder again where our adder is. We're going to go backwards. I'm going to go here. And oh, look at that. We have 2 things recently created. I'm going to go into here. We're going to sort by type. I actually want it the reverse way. Cool. And if we look, oh, hey, look. It created a C file called 2 4-bit adder. And it's also created a few other files. The other one we care about is this ELF file. So this ELF file is 265 kilobytes, and this C file is 19 kilobytes. So one of the questions in the lab asks, hey, how does that compare to what we've done previously? So in Lab 1, I have my Lab 1 folder up here. So if you guys remember in NXP, you had all these folders, and we asked you to add stuff in them. In Lab 1, we had to do, oops, I went to do the source first. In Lab 1, we had you write all this stuff. So if I edit with NXP, you can tell here's all that good old GPIO and editing of the dip switches that we had you do earlier. Now we're just going to look and see how big it was. It was only 5 kilobytes. Compared to what we created over here, which is 19 kilobytes, this is significantly smaller. Let's take a look at the ELF file. So if I go back here, I can go into Lab 1, which is all that build stuff. And if we look, the ELF file is 449 kilobytes compared to here where the ELF file is only 265. So this has the larger C file, but the smaller ELF file. And compared to this, this has a smaller C file, but larger ELF file. So this is the code we wrote. This is the code Simulink wrote. So quickly before I forget, let's look at that demo. So as in Lab 1, we want to make sure that these dip switches represent our binary numbers, this being the first binary number, this the second binary number, and their addition shows up here. So let's just quickly do some basic maths. We got 1 plus 1 equals 2, 3 plus 3 equals 6, and then all of them on should equal everything except for that first light on, which is what we see. So let's turn them off, make sure turning off works, and looks good to me. So that's the first part of the lab, and stay tuned for the next.